Hello and welcome to The Most Significant Bit, the podcast where we explore the unexpected connections between engineering, technology, humanities, and the arts. I'm Connor Bartos, and today we're diving into one of the strangest and most impressive natural engineering feats on the planet, the adhesive superpowers of gecko feet, and how this tiny biological miracle reshapes modern manufacturing, robots, and even space exploration. In this episode, we're going to unpack three big ideas: how geckos pull off their gravity-defying climbing abilities, how engineers decoded the physics behind their microscopic toe structure, and how that discovery led to the breakthrough technologies from reusable dry adhesives to wall climbing robots and NASA's microgravity grippers. So, let's get into it. Let's start with the obvious question. How in the world do geckos stick to everything? So for a long time, people assumed that geckos must use some kind of natural glue. Maybe their feet were sticky, or maybe they curled their toes around and gripped onto things, or maybe they had even little suction cups. But when scientists finally looked at the gecko toes under extremely powerful microscopes, they found something way cooler and stranger. So gecko toes are covered in millions of microscopic hairs called setae, and each of those hairs are split into hundreds of even tinier structures called spatulae. And when these tiny structures make contact with a surface, they create a massive amount of microscopic attraction. The attraction isn't glue, it isn't suction, it isn't moisture, it's physics. And specifically, it's van der Waals forces. It's the same weak intermolecular force that helps molecules stick together. And the wild part, geckos don't need any liquid, resin, or even chemical adhesive, and their grip is completely dry. It leaves no residue. And they can turn it on and off instantly just by changing the angle of their toes. It's like having millions of microscopic switchable hooks, except they're not really hooks at all. They're So once engineers understood what geckos were doing, the reaction was basically, okay, cool, let's just make the tiny hairs when they're trying to recreate it. And then they're like, how hard could that be? Shouldn't be that hard, right? It's just a bunch of little hairs. Well, it turns out it's pretty freaking hard. So the first synthetic gecko adhesives, they worked once or twice, but as soon as they got dusty or dirty, they just stopped working. They couldn't self clean. They couldn't like reset them. They couldn't peel. They couldn't peel off the way the geckos do and then restick. And there's no way they could be reused thousands and thousands of times. So that's when researchers realized that geckos weren't using tiny hairs. They were using like they weren't just using the tiny hairs. They were using like an entire system of hairs. And every small little detail mattered. So the angle of the hairs, the stiffness of the material, the spacing and the pattern of the hairs, and the way the geckos actually peel their toes off the surface. And and even their natural movement of just the way they move factors into it. So, engineers had to rethink everything. They tested different polymers, different micro patterns, different angles, and different manufacturing techniques. They are basically trying to reverse engineer millions of years of evolution. They measured things like adhesion strength, reusability, their ability to self-clean, the durability of them, and the ability to manufacture them at scale. But slowly but surely, synthetic versions started getting closer and closer to the real thing. And eventually, the researchers created dry adhesives that were similar to the gecko toe structure, and they were strong, reusable, residue-free, and very reliable. And that's when things got exciting, right? So, once synthetic geckos became reliable, the applications just exploded. So, robotics was the first people to take advantage of it. Robotic grippers using the gecko-style pads were able to pick up delicate objects like glass, electronics, and even soft materials without crushing them. Because before, if you're using like a claw on something delicate and fragile, it's just gonna break it, and suction cups aren't gonna work because of how small they are. And some robots have even been able to climb walls using gecko pads, which is just completely wild. And then manufacturing quickly followed. So gecko adhesives were also perfect for microassembly, especially in electronics, where traditional adhesives or magnets, they would leave residue behind, and in these ultra precise, controlled environments, those residues just were unacceptable. And since these dry gecko-inspired adhesives were able to pick up things without leaving adhesive or residue, they were perfect. But in my opinion, the coolest application is their use in space. So in microgravity, suction cups don't work, and magnets don't work either. And traditional adhesives are messy and unreliable in space. So NASA developed gecko-inspired grippers that can latch onto objects in space using their dry, attractive adhesion powers alone. So it's like, imagine it's so cool. So imagine an astronaut grabbing floating tools or their equipment or stabilizing like entire satellites, and all of them are using gecko style freaking toe pads. It's a perfect example of how nature solved a problem long before humans even knew it existed. With that, that basically wraps up today's episode. Today, we explored how geckos pull off their gravity defying moves, how engineers decoded the physics behind those microscopic toe hairs, and how that discovery led to real technologies that are now being used in robotics, manufacturing, and even outer space. It really is a reminder that sometimes the most advanced engineering starts simply with paying attention to the natural world because nature has already done the R&D. All right, thank you for listening to the most significant bit. I'm Connor Bartos, and we'll see you in the next episode.